Hello there. In this video, I'm going to show you how to finally start the debug process using KGDB, and I will show you how to prepare the target machine to start creating breakpoints and how to trigger them. Triggering breakpoints in the target machine will be a little bit tricky because the functions that we're going to trigger are really low level. So they are being called by a lot of processes. So for example, let's suppose that you want to create a breakpoint in a function to open a file or to open a folder, or like a function that is like really simple. There might be processes in the background that actually call this function. So sometimes you might be working and then like, oh, the target machine got like it froze because it's like one of these background processes just called a function, right? So I will show you how to trigger the specific one that we're going to work with is to create a directory. I'm going to show you how to create a breakpoint and how to trigger it. And also, one of the things that we need to do before doing that is that I will show you how to turn off basically this characteristic, the address space layer randomization, right? What happened is that actually the kernel has this one, like the address space layer randomization activated. What it is basically it's a way to prevent attacks. So it assigns random random addresses in the memory for processes. The problem is that if it is random, GDB doesn't know where the function is, so you will not be able to debug. So for example, like this is the address space layer randomization is called ASLR, and for kernel is called KASLR, right? So I will show you what will happen if what happens if you don't turn this off. Let's suppose that actually right now this is our scenario. We have the machine, the target machine waiting, and we have the host machine with the compiled like source code that we copied from the last video, right? So let me show you what happens if we try to create a breakpoint and trigger it like this, right? Without turning off the address space layer randomization, okay? So in order for us to do that, let's go here, right? So we're going to basically go to the folder we created last time, right? That has the VM Linux file. So we're going to access as root, right? So with GDB, we're going to connect to that one, okay? And what we're going to do right now is that we're going to connect to the target. Remember that actually, like the serial ports, they need to be connected, right? So in this case, you see here it has like a green dot, so it's connected, and this one is also connected, okay? So target remote, right? And now we are connected, right? So we're going to basically create a breakpoint. In order for you to create a breakpoint, you normally just type a break and then the name of the function. So the function name is a function in kernel. It's not like in user space. So I will show you, like we're going to create a breakpoint on this function, make dir at. I will show you later where do you get this name, right? So right now it's there, right? So it seems that the breakpoint was created, right? But if you continue the thing, basically it tells you this, like cannot insert breakpoint, cannot access memory at address, this one, right? What happened is that actually this happens because as I told you, like the ASLR is still activated, right? So the computer here, well, yes, okay. So we are going to basically turn it off. So in order for us to do so, let me just let's close this one, right? So I will show you here. Okay. So right now we're going to start here, okay? Let's do something. For sake of simplicity, we're going to separate these ones. And let me see how can I do this. There you go. So that way we can see both machines. There you go. Okay, And also I'm going to do this for this one. I'm going to activate the seconds, right? So we see that actually this one is moving, right? So because like in later steps this machine is going to stop working, I mean like it's going to freeze, so we can see that actually this one is working. We can just activate this one as well. And let me take a look. Oh, it's out of sync. Sorry. Okay. There you go. So the machines are in sync, right? Okay. And also add something. Sorry, this one I didn't activate this one. This is just optional. So okay, this one is here, and this one. Sorry, I'm just going to activate this. Oh, it's here. Okay, so no problem. Okay, so in order for us to turn it off, what we need to do is that we need to basically modify the GRUB, right? So we're going to go here, like default GRUB, right? Okay, so basically for this line, this is like command line Linux default. We're going to add no Kernel ASLR. Okay, so basically that's how it's supposed to be, right? And we're going to basically close it. Okay, there you go. And then we're going to update the GRUB, right? There you go. But every time that you run this command, we need to modify the grub.config file, right? So what I mean is this one. It's like if you go basically to here, grub, there is a grub.config here, right? So do you remember that actually when you look for the word Ubuntu, right? The first line, like this one, Linux, we had to add the, now it says here no KASLR, right? We need to add the commands, right? So we need to add KGDB wait and that one, right? So we're going to do that right now. So basically it's like here, grub and grub.config. Okay, so we're going to jump to the line. Which line is it? This one is line 148. Okay, so 148. There you go. And we're going to add the commands again, right? one. Please remember that actually this S is capital S, okay? Because it's like this is like a case sensitive system, right? So there you go. And we save it, right? So basically that's it. Before proceeding, I will suggest you something. This step that I will show you right now is optional, but it will make your life a lot easier, right? What happened is that we need to check for this kernel source code. So either you check it online or you re-download it. Like we downloaded the kernel source code in the target machine, right? If you remember, it's here in the USR source, right? It is here, right? But the problem is that this machine is going to be waiting for the KGDB commands from this machine. So if you need to take a look at the source code, you will not be able to, right? So then you need to either re-download the kernel source code here. So I have it here. Just the source code. You don't have to compile it. Just basically we need the source code, right? That one, because like here, for example, in this one, we will see like some C classes, right? So these are the ones that we're going to use, for example, in FS, but we're going to use other ones, right? That one, or there are like websites online that actually shows you the source code of this one. I will leave a link in the description below, but I will suggest you like because the online versions might not be completely in sync with what you downloaded, so it's better for you to re-download from the same source, so you like both machines have exactly the same files. Okay, so what we're going to do right now is just basically restart the computer, right? We're going to restart the target. Please keep in mind that actually the serial ports, they need to be always connected, right? And we're going to basically this one. Okay, so here just let's check that everything is okay. There you go. So everything is okay, and this is no KASLR, right? Okay, so let's start it, right? And we are going to basically wait here. Okay, I'm going to basically here GDB, I'm sorry, VM Linux. There you go. Okay, so now you say here, like you see here, when the computer, like when the target machine is restarting, it says like no KASLR, right, on command line. So you will see this new line. Okay, let me see if I can make it. No, it's okay. It's fine. Okay. Okay, so target remote. Okay, so we are connected now, right? So okay, so right now, well, I told you that actually if you turned off this, then the breakpoint is going to get hit. But uh, uh, how did I know that actually that was like the function that we need to use, right? So what happens is this, like in the host machine, or in the machine where you have the source code, right? So what you can do is basically check on the, for example, here in the um, in the kernel source code folder, right? You need to go to arc, and then like for this one x86, right? And then we're going to go for entry here, syscalls, and this one syscall underscore 64 table, right? So that one, basically, this is like a list of the system calls that actually your kernel has. So if you can see, there are a lot of them, right? You can also search online for the system calls of other kernels, right? So for example, when in later sections, if you wanna add a system call, basically you just add it at the end of this file, and basically you need to add to also add this consecutive number, which will be the system call ID, right? So in this case, we have, like, for example, read, write, open, close, right? So when you in C, when you do like a printf, right, that's a write, right? So when you open a file, it basically calls this open function. Also, when you for example write into a file, it's also the write, right? So in our case, we're going to check for the make dir, right? Make dir. So here you go. So here's the make dir, right? So okay, so now you have the ID make dir and basically this one, right? But we need to look online, or well, I'm sorry, we need to look where this function is implemented in the source code. There needs to be somewhere some file around here that has this function implemented, right? So for you to do that, what I would suggest is to check online for like searchable Linux syscall tables, kind of like this, right? And then they will have like the system call, the ID, like the entry point, and also like where is it implemented in the code, right? So for example, make dir, right, is here. So it has to be consistent. Like you have to be careful that actually like whatever system call table you found is from that kernel, and basically it's for Linux, right? So here's 83 make dir, okay, make dir, and it's in the fs and name i.c. So we just go here and the fs folder and name, here you go. Okay, so like this file if you see is quite big, right? So it has a lot of functions inside, right? We need to look for this one specifically, right? So what we're going to do is just, when you look for a function in this file, you need to look it for something of the form syscall underscore define, right? So here you basically say, okay, so if when you look for syscall underscore define, then you will see an integer number, well, a positive number. So, and then you will see the function, right? So here is like this one, here's this one, and then you see the parameters, right? and then this is just basically a wrapper, and this is the kernel function. So in this case, for example, like this function basically calls this one, right? This is just the wrapper, right? So we need to like look for a like an entry of the form syscall underscore define, and it needs to have make dir here, right? So when we keep looking for that, right? So here we go. Here we go. So it's here, like it's syscall underscore define make dir, and basically it calls the function do underscore make dir at, which is the one that I showed you at the beginning, right? And as you can see here, it has like these three things as parameter, right? So we're going to basically debug the kernel, and we're going to display this value, the path name. Okay, so what we're going to do right now is that okay, so we are already connected to the remote machine, right? So okay, now this one is waiting for it, right? So we need to basically let this continue, and then we will create the folder, right? So if you just say continue, right? So the machine is going to start as normal, right? And there you go. Here, let me see if I can, now it works like this. There you go. Okay, so here we have that. Oh, just one thing, I will suggest you in the target machine to open the monitor, just like here, monitor, like system monitor, right? And basically check on the resources, because it's like this thing is going to show you a graph, right? And it will show you like it is moving and changing, right? And also that's the reason why we activated the seconds, because it's like when this machine like stops, when it like freezes, then we are going to be able to see, okay, so right now is waiting for this one. Okay, so like right now we see the machine running, right? If we create a folder, let's suppose that we create here like a new folder. So yes, test. As you see, the machine is still working, there's no problem, right? So then how do we trigger this? Like right now we lost control in the host machine, right? Oh, sorry, we lost control in this one. We cannot basically continue here, right? I mean, like we cannot create any breakpoints, so we need to give make the target machine to give control back to the host. So for us to do so, what we need to do is basically do like this. Let me see if I can make this a little bit smaller. I wanted to, so we can see that, and I think it's okay. Okay, so yeah, I think it's fine. Okay, so what we need to do is to access as root, right? And then we're going to type this command echo, and then plus, and this one trigger. Okay, so then if you see like the machine, like the target machine stop, right? So here is like it's frozen, right? And this one is still working, right? So like even the graph stopped, right? So now we got control back in the host machine, right? So what we need to do is to create a breakpoint. So remember that actually we need to check on the source code and basically use this function, right? So we want to use the break and make dir at. Okay, so if you see here, actually when you create the breakpoint, it basically tells you like the file name where it is, and even the line, right? 3827, and it is quite close to where we are right now. Okay, so if we tap continue, right? So it's continuing, right? So the machine, okay, this is what I was telling you, right? The machine stopped again because like right now there are like some background processes that actually are creating folders. Like for example, this one is a temporary, right? So that continue, and like you have to type continue several times until you get out of the background processes. Okay, so that will take just a couple of minutes, right? So yeah, we got control back on the target machine, right? So you see the clock is moving, and also you see the graphs here moving, right? So if we just, like, for example, right now this is the desktop. We're going to create a folder in the desktop, right? So we can do it in two ways, like either graphical or by terminal, right? But let's suppose that we just right click and new folder, right? So it's stop, right? So here we trigger the point, right? So like here we have the three parameters. Let's suppose that actually I want to see the path name where we are creating the folder, right? So for us to do so, we need to basically type print and path name, right? So as you can see here, basically it says, okay, so it's in home, my user desktop, and well, right now it's called untitled folder, right? So as you can see here, basically we reach the breakpoint, we trigger it, and we are able to print the variable, right? So we type continue. Continue. Oh, it's because like let me see a second. Continue. It's delete. Okay. Yes. Continue. Okay, there you go. So it was because it's like like some of the process here got stuck, right? So we can just try to do it again, right? So let's do it by terminal this time, right? So here, okay, and we're going to create the breakpoint. So break to make clear at. There you go. So continue. Yeah. So right now it's moving. Okay. So let's, in a new terminal, we're going to create a temporal file, temporal folder, right? So here and test folder. Okay, so we trigger it, right? And if we print the path name, there you go, test folder, right? Continue. So then you go and you get back the control again on the target machine. You see the clock is moving, and basically the processes here, like the graphs, are moving around here. So you see that actually is changing, right? Like as you saw, like if you want to delete well, if you want to delete a specific breakpoint, when you make a breakpoint, it tells you the ID, right? So you can either type delete, for example 2, or delete 1, like whatever ID you get, or just delete and it will delete all the breakpoints, and you just type continue, right? So in this case, right now we already got the control back on the machine, right? There might be a chance that actually a background process, like a temporal, like as you saw here, basically creates a folder and it will give the control back, right? So this is basically how you debug and basically create breakpoints. Again, creating breakpoints on the kernel functions, it's, I wouldn't say it is that difficult. What happened, like the difficulty is mostly on triggering them, because it's like if you want to trigger just one, it's a little bit tricky, as you have background processes that might also be calling that. Okay, so in the next video I'm going to show you how to well, this video covers basically finishes covering what is KGDB, right? In the next video I'm going to show you how to create the profiling tool. Like we're going to use a profiling tool to profile the kernel, and then I will show you how to profile these functions, right? So because it's like you want to see how much time, how long does this function takes, right? Or for example, let's suppose that actually you have, when your computer is booting up, it takes a lot of time, so you want to see what is taking, so why is it taking so long, right? So I will show you how to profile some kernel functions, right? But because we have a custom kernel, right? Because our kernel is a custom kernel, we cannot use we cannot just download it from Ubuntu repositories. We have to build it. So I will show you how to do it, and how to profile some of the kernel functions.